And I'd like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcasts. And thanks again for joining us for today's MSDN webcast, Visual C# 2010 Soup to Nuts. Today is Part 8, Operator Basics. Now, without any further delay, I'm going to turn the floor over to today's presenter, William Steele.
Thank you, Tracy, and welcome back, everybody, to our 8th in this series on C# Soup to Nuts. Today we're going to be talking about operators and what they're going to be doing for you. An operator is very simply something that helps us work with expressions. It helps us make decisions in applications. They're commonly used throughout Visual C#, as well as most other languages. So let's start off. Today we're actually going to be talking about the whole bunch of different types of operators. Starting off with a very simple, what we call the assignment operator, probably one of the most used features of it, because the assignment operator is generally used along with all of the other operators at one point or another. And then we'll move into some of the more useful operators, things like the arithmetic operators and relational operators that help us make applications that actually perform functions. So we'll see exactly how these work. And then we'll wrap up today's session with a look at a concept called operator overloading. Operator overloading is a feature inside of C# that allows a developer to create their own custom objects and then utilize some of the features like an operator within the language to allow their own custom objects to, for example, be added together or be multiplied together like we traditionally would see a number being done. So we'll see how we can actually build a very simple overloaded operator and what the uses for that will be. So starting off with a very simple, what is an operator? An operator is not the person at the other end of the telephone when you dial 0, and that's not going to actually help us here. In fact, an operator is simply a symbol that defines some kind of an operation that you can perform on one or more expressions. So an expression is, if you remember from our previous sessions, is basically the portion of our code that gets evaluated to make decisions, to do results, things like that. And the way we actually make those evaluations, we utilize a component called the operator. So 1 plus 1, for example, the plus is the operator. We are applying an operation to two values. In that particular case, the plus happens to be the summation operation. So how does this work? Well, we have a whole bunch of simple ones here. Like I just mentioned, we have the very simple addition or plus. Now, generally, when we think about a plus sign is basically you taking one component and adding it mathematically to another component. So I can take the value 1 plus the value 2 and add them to get the result 3. But interestingly enough, we as humans actually have other concepts when we say add. So if I have two letters and I add one to the other, generally when we think about adding, we're not coming up with two letters per se, but we might actually have a word. So the result isn't, the 1 plus 1 equals 2. It might be 1 plus 1 equals 11. So that's a concept of adding strings together to come up with a result. And when you think about the differences between those two, especially to a computer, what you wind up with is, obviously a function that is doing more than meets the eye. Because when we add 1 plus 1 as a numeric value, we are using the mathematical operation. But when we add 1 plus 1 as the string values or the literal values, and we get a literal result of 11, we actually realize that that's actually copying bits in memory and pasting them in such a way or placing them in memory in such a way that they're contiguous. So we're concatenating those true strings together, for example. So that is an example of operator overloading, where we have it performing one action on one type of data and an entirely different action on a different type of data. And this happens to be a great example of operator overloading that's built into the system. But later on we're going to see that we can actually apply this operator overloading to pretty much any type of functions or classes that we want to define within our own code. some of the other arithmetic operators that we're going to deal with are going to be the standard math type functions, so adding, subtracting, multiplication, division. There's even some ones that you don't use very often, like the modulus, where you can calculate the remainder of a division operation, for example. You can also, there's various other types of operators. Now, one other type of operator that's actually really important when we're dealing with, for example, these arithmetic operators, is the ability to store that result. And we use what we call the assignment operator to store those results. The assignment operator just happens to be the equal sign in C#. And you'll find that in C#, in most languages, it's the equal sign. However, that's not generally, that's not always the case. So, for example, there's a language called Spin that I'm aware of. And the assignment operator in the language called Spin is actually the colon equals. So you have two characters next to each other indicating an assignment of a variable. Now, the nice thing about the assignment operators is that they can be combined together with arithmetic or any other type of operator that we have. And generally, you would do this when you want to store the value as well as add it or subtract it from another value at the same time. So by combining these together, you wind up with a kind of a compound operation that you're applying that you can use to shortcut or create a shorthand version of a set of code. The classic example would be adding a value 1 to an integer. So in a lot of cases, you might say A equals A plus 1. Where in C# you can actually do an A plus equals 1, or even an A plus plus, as a matter of fact. There's very simple ways of doing that, and what it'll do is it'll allow you to assign it as well as apply the mathematical operation to it at the same time. So let's go ahead and pop out to our first demo of the day and take a look at some of these assignment and arithmetic operators and see how they can actually be used to very simply do some quick little functionality within our code. Now, when I move to my next slide, it's going to take me out to my screen sharing demo. And the next slide, my screen is set to 1024 by 768. So if your screen is set to that or higher, you can press the F5 key and maximize the screen to see my entire screen. And then when you're done, you can press the F5 key again, and that'll restore the display back to the normal live meeting console window. And as always, feel free to ask me any questions. Simply go to the questions and answers panel and type in a question. And when I come back from doing the demo, I'll actually see that in the QA manager, and I'll answer all of those questions that I see in there verbally. So off to our first demo. So what I've done here is I've actually created a very simple application that has pretty much all of the demos that we're going to be doing today on one screen. And I've broken up each one into 3 different sub-demos. So starting off with the assignment operators, we can see that I have an equal sign here for this one. This is the very first assignment operator. I want to double click on it. It simply takes me to the code behind that shows us how to implement that. Now I have 2 methods here that are just helper methods that allow us to interact with this user interface panel here. I have these 2 values, value 1 and value 2, that are simply text boxes that allow me to type in various mathematical values. And then I have a label that's kind of hidden called output here. And the output label will simply display the results of what it is I'm doing here. So when we first start off, we can see that I have an assignment of a variable called A, and if we actually look at our helper functions, we have a helper function called getValues. First off, let me move to getValues so you can see that. And what I'm doing there is in the variables A and B, I'm simply reading text box 1 and text box 2's value. The values from those 2 text boxes. And then to display the answer, I'm simply taking whatever value I pass into it and actually popping that into the output text window. There's a couple different variations of this, one depending on whether you're giving it a number or not. But back over to our assignment operator here so you can see how this is working. What I'm actually doing is I'm reading the value out of this first text box, and I'm simply assigning it to a new variable. In this case, the new variable is C, and I'm telling it to go ahead and display the value C. So the assignment operator is simply the equal sign here, where I'm taking one value and I'm copying it or replacing the value of the C with this new value A. So when we run this, we see that as no matter what number I type in this value 1 box, when I hit the equal sign, it displays the output, basically the same window that we have, the same value that we have up here in this window. Now, the second one that we have next to it is one of those compound versions where we're taking the original value, whatever it happens to be. In this case, C happens to be, whatever the default is. And then we add a 5 to that value. So in this case, we're taking the original value. Let's say 0 is the original value. The first time I run this button, first time I click this button, the value will be 0. And what it will do is it will add 5 to that value. So 5 plus 0 is then going to get stored back in that value. So the second value would be 5. The second iteration of that, the original value is going to be 5, so 5 plus 5 is equal to 10, so it'll store the value 10 back in there. So when I run it this time, using the plus equals, I have the original value is 5. Again, we get 10. So in this case, every time I click it, we're adding 5 to whatever the value is stored in this variable that we're displaying here. That happens to be C. Now, the last one in this case happens to be the opposite of that, where we take the original value and we subtract a number from it. So that we're going to subtract 3 from whatever the value is stored in the C variable. So if I click on this, we get a -3. Now, this value was C, so we didn't actually have the original value A inside there. So with the -3 is correct. The default value for C would have been 0. And every time I click it, the value goes down by -3. So hopefully that gives you an idea of an assignment operator and how those actually work, along with the addition of the arithmetic operators. Now, let's go look at the arithmetic operators themselves. In this case, this is a non-shortcutted version. Because we're not adding a fixed integer, with this type of operation, we can actually deal with multiple types of values or multiple values themselves. So in this case, we have variable A and variable B that we're applying the addition operator to. And then we're applying the assignment operator to. So we're going to take the result of these two, take the result of this operation here, and store the value in this variable here. So A plus B equals C makes pretty simple math. So here we have a value of A is 5, the value of B is 7. So the value that we should get displayed here when we add them is going to be 12. And then we can go ahead and look at the other code for these as well. We have the multiplication. So the star, the asterisk on your keyboard is the multiplier. And this last one is we have this modulus value. So this would be the kind of like a remainder here. So let's go ahead and run these. So we have multiplication. 5 times 7 is 35. And here we have this modulus value. So 5 times, this is the modulus value of that. We can even change this if we want to see, for example, the divider. If you want to divide one by the other. And let's make this 35. And here we'll do the divide, and there we get a 5. So in that case, we have the division of those two. And there are several types of mathematical operators. One of them is this caret. That's actually where you're raising the power of one to another. And so there's various types that we can use there. Those are the arithmetic operators. And again, just like we did before, we can actually combine a lot of these with that. So for example, you might be able to do the star 5 like that. Or whatever it happens to be. There's a lot of those that we can do. Combining them together allows you to basically shortcut or shorthand, if you will, the values. Now, one other type that we can do here, one that I haven't actually shown you, but we talked about, was in our assignment operators, we could do, for example, instead of doing this first one, let's do a C equals, let's just C++ like that. So this isn't the C++ language. This happens to be an operator that's actually taking the value 1 and adding it to the variable C. So C is getting added to itself. Now, this is an unusual syntax to see that, but this is one that you can remember. It's a very simple way, especially if you see it in somebody else's code. This just means simply increment the value of C by 1. So now when I hit this, every time I do that, every time I click that button, it'll simply increment the value by 1. And likewise, if I do the minus minus, what we'll wind up with the decrement value. So as I go down, the value gets smaller each time we iterate over it. Okay. So hopefully that gives you an idea of the very simple assignment and arithmetic operators. Now, another type of operator that we're going to perform with quite often is something that we call a logical operator. Now, logical operators help us actually do some bitwise kind of comparisons, if you will, and have a result that we can actually use to compute a logical or a path that we can take in our code, so a branching decision, for example. In a branching decision, you have an expression that is either evaluated to true or false, which happens to be the Boolean data type. So the Boolean data type is a positive, it's a 1 or a 0 kind of value. Technically, it's a -1 or a 0. And with that type of operation, you can actually do classic computing style things. So the logical operators that you would do on, code, for example, is you might AND two values together. So if this one and this one, then, take some action. You might even do an OR kind of thing. So one value or the other one. And I do have to point out, I just realized I made a mistake, a wrong language here. I used the caret sign earlier to indicate a raise to the power of. Actually in C#, it's 2 asterisks together allows you to raise the power of. This happens to be the caret symbol happens to be the exclusive OR logical operator here, which space my mind kind of slipped a second there. So you can see that we have this logical bar symbol, which is one value or the other. So this is the piping on your keyboard would be the shift backspace key. We have the caret indicating the exclusive OR, and we have the standard negation sign or not sign, which is the exclamation point or bang. And we use this one quite often. So if a value is not true, for example, you can say bang true, or technically you can say the word false. But if it is an expression that you're actually evaluating and you want to look at the opposite of it, you can simply use the exclamation in front of it, and that'll do a logical operator not applied to it. So some of the other options that we have here are some bitwise things. So for example, we have the tilde sign, which is the complement, the bit complement. So basically it takes all the bits within a value and flips them. So a 110 becomes 001. So each bit becomes the opposite of what it was before. And then we have some conditional values there. And then lastly, interestingly enough, we have true and false are actually logical operators. They actually evaluate to values, but they have to be processed. So this is a command that we're given to the C# compiler, and it actually has to be evaluated somehow. So the way we under the covers do it is we have this true and false operator taking care of that. Now, another type of operator that you're going to be using quite often with this is are operators where you are comparing one value to another. So we saw the logical operators that allow us to evaluate to a result of true or false. However, you're generally going to be comparing different types of data. If you're dealing with logical data, bit data, it's pretty easy to deal with the logical side of it. But if you're dealing with more complex objects, a lot of times you're going to need to, if you had to deal with it in logical, you would have to convert it from whatever the standard data type was into something that was more logical or more bitwise. But generally what happens is, with a more complex language like C#, they actually have features built into it that allow for these operations, these complex operations to perform without the need for converting that data. And that's where these relational operators come in as an example. In this case, I might be able to compare two complex values to each other. Now, the comparison operator in a lot of languages is the equal sign, but in C#, the equal sign is the assignment operator. Now, for example, Visual Basic, the assignment operator and the comparison operator, the is equal to operator, actually are single equal signs. But in C#, the designers of the language wanted to make sure that it was different so you could visually see which one you're using. And this is actually going to be a common mistake that a C# developer is going to make, that they're going to try to use the assignment single equal sign operator in a place where they should be using the double equal sign, which is actually the comparison operator, where you want to compare one value to another. So the example that I have here is if A equals 1. In this case, it's if A equals 1, which indicates that this is a comparison. We are comparing the value of A to the value of 1 to see if they are equal. And that'll return a logical true or false, true if it is equal or false if it is not equal. And likewise, we have the is not equal using that bitwise not sign. So we're comparing to see if a value is not equal to some other value, it's going to be bang equals as opposed to equals equals. The other types that we have are for checking the values to see if they are different, as in like a greater than or less than sign. So in a greater than or less than sign, you're simply using the open or closed brackets here. And then lastly, is greater than or equal to, it's is greater than or equal to, or is greater than or less than or equal to. So in this case, we have the greater than and less than in front of an equal sign. And you want to be careful with the order of these. This is actually, in C# important. In VB, it turns out that in some cases you don't have to have the order correct, but C# it is order dependent in this case. The easy way to remember it is it's always going to be the odd character. The non-equal sign is going to be the front character in a relational operator here. Now, another type of operator that we might have in there, and I've kind of already talked about some of these, are the increment and decrement by 1. The increment and decrement actually, interestingly enough, are plus plus or minus minus. And what's different about these is that they have the option of having the plus or minuses in front of or behind the value that you're altering. And this has a subtle difference in the two, and that one actually adds it before it assigns it to the value A, and the other one does it after it assigns it to the value A. So you want to be careful with that. That order is slightly different. However, both are completely acceptable in this case. It's just that you want to be careful of which one you're using. Generally, if you're going to add the value after the process, you want to do this. This is showing you that the add signs are after the assignment of it here. So the other type of operator that I find useful, especially when you're dealing with graphics and a lot of low-level stuff, is the classic shift operation that occurs inside of binary math and things like that. And in C#, we actually have the double brackets, greater than or less than, indicating which direction we want the bits shifted by. And this operation actually allows us to shift the digits, the binary value of the values that you're dealing with, left or right, depending on which one of these you're choosing. Now, you can actually tell. In this case, it's actually saying this demo here. It says A less than 1. This means we're going to shift the bits left by 1 bit. If I put a 3 in there, it would shift the bits of the value A left by 3 bits. And then naturally the other way is shifting to the right. Now, in this case, you want to be careful. When you're shifting these bits, it will drop the values off. If you're shifting to the left or shifting to the right, the values that you had there initially are actually going to get truncated. So you want to make sure that you handle that correctly beforehand. You understand which bits are actually going to get dropped off, and if you need to store those, what were they basically. So you want to be careful of that. Lastly, we have this other interesting one that's what we call the conditional operator. The conditional operator is actually the question mark. And the question mark actually has a second operator that's applied to it all the time, called the it's the colon sign. And basically what the question mark colon does is it's basically like a very simple if-then statement. So we actually have an expression where we actually pass the question mark and it checks the expression. And if the result of this expression is true, then it will process this expression called in the true section. Otherwise, which is the colon symbol, otherwise it will process the value in this third expression, which happens to be the false expression. So you can actually return the values true and false, or you can have additional expressions applied in here. And then obviously using the assignment operator, you can take the result of whichever one was the answer to this question, if you will, and store that in some variable. So let's go ahead and pop over and take a look at some of these logical and relational expressions here and see how they can be used in C#. So back over to my demo machine. Back in our code here, we have our logical expressions. Now, we already saw the plus, plus, and minus, minus, so we'll skip those. But here is the logical AND, where I can take two values and AND them together. Now, I've done one other little thing for this demo, and that's I wrote this little method here that takes the numeric values that I've entered into the text fields and converts them to a binary format for output. So we'll see the conversion to ones and zeros so that we can actually see the logical AND value or the logical process occurring here. So let me go ahead and show you that. Let's do do the AND value. In this case, we have two values that we're basically ANDing two values together. So if I do a 1 and a 1 and AND those together, I get a 1. If I do a 1 and a 0 and AND those together, I get the 0. In this case, it's taking the logical result of these and combining them together if they are ANDed. Now, in this case, if I do a not, I actually get a true. So if one is not the other, then it's true. So in this case, that's the not value. Actually, in this case, I'm just saying, hey, this is not false. I could have compared this, done some other operation to that, but in this case, it's converting. It's basically taking the not value of false. So if true is obviously not false, so that tells us that we have that not value there. Now here is a logical OR on two values, A or B. We go back and run that. So if I have 0 or 1, I should wind up with a 1. Or if I have a 1 or a 1, I wind up with a 1. But if I have a 0 and a 0 in here, when I do that, I get a 0 because neither one of these values evaluates to a true. In other words, neither one is greater than 0 in this case. If neither one evaluates that, then we actually wind up with no value at all. Now the relational ones, here we have a relational one that's actually comparing two values. And the way it's comparing them is checking to see if they're equal. Is A basically equal to B? So we have the relational equality operator, is A equal to B? And this will return true or false by itself. And then what we'll see is V is actually going to take this comparison and give us the result of true or false. So here I have 0 and 0. If I do the relational, I get the true value. But if I change this and I do the relational, now I get a false because A is not equal to B, and the result is going to be false. So that is the relational equality operator. The other operators that we have there are greater than. So we have if A is greater than B, or in this case, if A is greater than or equal to B. So again, if we go back to our code, if A is greater than B, which is true, or if A is greater than or equal to B, which is true. So if I go to here and I put a 1, this is false. But if I use this same function over here, this is true because 1 is equal to 1, and in this case, 1 is not greater than 1. So this lets you see the logical and relational operators as well. The other type that we have here is we have, I already showed you this one where we take some value and we add 1 to it. Here we have the logical shifting operators. And let's just take a look at that code so you can see what that looks like. Here is a logical shift where we're going to take a value and shift it left by X number of bits. So if I have the value 1 and I shift it, let me shift it 0 bits. This is the binary value 1. So if I take the value 255 and display it, we get all 1s. But if I shift this left, or shift this, in this case, right by 1 bit, I'm moving all of these bits over 1. Well, because we have nothing over here, this first 1 is going to drop off. But all new values coming in from this side are actually going to be 0. So here I'm shifting it by 1. Here I'm going to shift it by 4. So we're going to have 4 empty values, and then the bit that was here gets moved over 4 bits to here, and likewise the next 3 the same thing happens to them. And I can do things like look at a 128 and shift it by 0. So we'll get this high order bit over here. Then if I shift it by 1, shift it by 2, as I shift it by 3 bits, you can actually see that bit moving over. And then obviously the less than will actually shift it to the left the same way. Now the last one that we have here is the question mark colon operator, which is actually the operation where we're actually checking an expression and actually determining whether the result is true or if the result is false. So in this case, it's checking to see if A is greater than or equal to B, then display greater than or equal to. Otherwise, that's what the colon is, otherwise display less than. So you can see in this case I have an entire if then else kind of thing all on one line of code. And this is what we like to call an immediate if statement. And as I run this code, that would be the question mark. So if our case is if that's greater than that, in this case it's greater than or equal to. But if I do 2, actually 2, Bill, here we say less than, so value 1 is less than value 2. If this is equal, we get greater than or equal to. So in this case, what we have is our code is actually doing exactly what we thought. We have an expression that we're evaluating using one of the relational operators, in this case, greater than or equal to. We're comparing these two values. This results in a true or false. If it is a true, it executes the first block of code before the colon. If this results in a false value, it will then execute this last block of code. And in this case, it's not executing it. It's just the expression that we're going to use as the answer, if you will, to this equation that's going to get assigned to this value s. So in this case, we have the ability to have a very kind of like an inline function or a lambda function that determines, a conditional statement. Okay, so back over to our code. Our slide deck. And let's talk about probably the most complex thing we've talked about so far out of all of our sessions. And this is this concept of operator overloading. Now remember earlier I talked about the 1 plus 1 equals 2 or 1 plus 1 equals 11. And that difference is due to the fact that you add different types of data in different ways. And in order for a computer to know what to do, it has to know how, in order to do it correctly, it has to know how to do it. And it has to actually know the type of data that you're dealing with. So what we do with operators when it applies to the different types is we have the ability to actually describe to a class how it should deal with certain types of operations. So when a user requests or a developer requests that you add one object to another, what is the definition of add, basically? And that definition of add is what you're describing here. You're overloading the plus operator in order to get it to behave the way that you think a plus operator should for this particular type of data. In other words, on the string value where you take one value and you concatenate it in memory to the next value to have a much longer value, not a bigger value like a number would be, for example. So the operator overloading allows you to define those particular types of operations that are important to your code or to your objects so that they behave the way that you expect them to. Now, I will be, warn you, real caution you very highly. This is a very advanced topic for this early in our session, but just keep it in the back of your minds that later on when you're building applications, if you have the need to do something like this, that this is there. C# is very, very powerful in this aspect, and it allows you to take these simple concepts that we think are simple and actually make them apply to much more complex scenarios. Now, there are a few rules around these, and any type of operator overloading must be available throughout the system. And in order to make it available throughout the system, in C#, we have to mark it as a static operation. So the way you do that is you use the public keyword static, and you apply that to whatever the type is you're dealing with. So in this case, this little bit of code here is overloading the plus sign. And it's, when we talk about a plus sign, you're generally going to take one object and add it to another, and you have to define what add means. And that's exactly what we're doing here. We're taking one object and adding it to another to create a new type of object. And then that functionality will be in the middle here. So let me show you the example that I have for operator overloading for our session today. And then we'll see how it actually works. So back over to our demo machine. Now, what I've done here is I've actually created a class that simply has a couple public properties in it. So it has an integer x and an integer y. And these values are simply publicly exposed so that we can use this class as an example. So in this case, though, it's a complex business object that has two subproperties on it. This can be literally any type of class that you want it to be. It can be, really fancy things or even just a simple integer if you want. But the idea here is that you have some custom functionality that you need to deal with. Now, let me just go ahead and, before I show you the code, go ahead and run it and show you what the result is. So here I have the instance of operator overloading, and I'm actually getting two values, 7 and 7, back out of this. Now, what we're actually doing is we're taking two instances of this, x and y, and we're actually adding them together. Let me bring up the code for that. There we go. I'm creating two instances of those classes, my custom class, and I'm simply setting some values, reading A and B from the screen, and in our case, A and B on the screen is both the value of 3. And so the first one has x and y equal to 3. The second one has x and y equal to 3 plus 1. So this is just a normal thing. So we're just storing the values 4 and 4 here and 3 and 3 here. I then go down here and I simply say, okay, take class 1 and add it to class 2. This is the overloaded operator that we're dealing with. And what I've done here is I've actually written a bit of code that tells the system how to add one of these custom classes to the other. So it's not just a generic add routine, it's actually defining what add actually means to the system. And then in our case, I then go ahead and store that value in a new class, and I simply display the results of that x and y. Now, I only have one plus sign here where I'm adding these two classes together. But you see when I run this code, I actually get two results out of it, x equals 7 and y equals 7. As a matter of fact, if I change this to 5 and I rerun this, I now get 5, which is this first one here, and then I get the second value is actually going to be 3, so 5 and 3. The second class actually gets 5 plus 1 and 3 plus 1, so we get 6 stored here, so 5 plus 6 is 11, and down here we actually have the B value, which is 3 plus 1, so that's 4. So 3 plus 4 happens to be 7. So you can see that this operator is actually doing double addition. Even though I only have one, it's actually adding A to A, or I'm sorry, the X value to the X value and the Y value to the Y value. And the way we actually implement that is in our class here, we actually have a static member that's called myClassOperator+. So we're actually overloading this addition operator here. So we're saying, okay, take the addition operator, and when we're executing this, we actually need two other properties. Two other classes. We need the first instance and the second instance of the class that we're dealing with. And you can see when we do that, we have the first instance and the second instance already defined for us. So we get those two, pass those two values in, and then in our code, I go through here and define what does it mean to add class 1 to class 2. And here you can see exactly what it means. Here in this case, it means add the two x values together and then add the two y values together and store them in the x and y. Now, if I wanted to, I could get fancy with this and say, well, let's make the second, whoops, let me stop running the code here. Let's make the second one a multiplication instead. So what it means to add these two classes is we're going to take the values in X and we're going to physically sum those up. But we're going to take the values of Y and we're going to find the product of them. So let me go ahead and do this. So we do our add. In this case, 5 and 5 plus 5 plus 1, so it's 5 plus 6 equals 11. And then over here we actually get 7 times 7 plus 1. So 7 times 8 equals 56. So in this case I have this very custom function that I'm using to define what this actually means. Now interestingly enough, I can actually take this a step further and add another one of these. Actually, I have to stop running the code first. So we'll paste that one in there and we'll put the minus operator. In this case, we'll do a minus and a divide. So here I have two totally different operators here. So I have the minus and the plus. And if I go back over to my code and change this to the minus, I now have a new operator for doing subtraction. And in this case, the subtraction is going to be totally different. So let's do a 35. Let's actually make that 49 so we can see it. And there you can see I get some new values coming back from that. So one value minus the other. Actually, this is always going to return minus 1 because of the way we did our code earlier. Our code actually was A and B, A plus 1 and A minus 1. So we're going to subtract this value from this value, which is actually going to give us minus 1 because that's what we've always done here. And then this other one actually is a division, and we actually are dealing with integers. The problem with integers is once you get below, there is no decimal. So once we get too low, the value drops away entirely. So we don't have any value there. So that just shows a different example of an overload. And interestingly enough, you can actually define your own overload. So, you might have a dollar sign or something like that you want to use. And defining the dollar sign or whatever, you would define those a little differently. In this case, we're overloading an existing operator, or you could create your own operator. So Visual C# is incredibly powerful when it comes to this aspect of development. So let me go ahead and restore this for later downloads. And we'll put this code back in here. There we go. Go back to run it to make sure everything works good, and it does. So that's actually how we get our custom objects to be able to add themselves together. Now, what's interesting about this is we can even do some really cool things. We can take our custom objects here, and we can even add a new property, for example. Let's make it a string property, and let's call it, text. So we have these two string text properties, and in this case, what we'll do is we'll take my class text equals my class 1 dot text plus comma plus my class 2 dot text. So in this case, what I've just done is I've added a string value to this, and what it'll automatically do in our string value is it's going to go ahead and take whatever gets set of these two text values, and it's going to go ahead and concatenate those together with a comma in between them, so we can have like a list of values. So let's do an initial value here. So we'll call this case class 1, and we'll call this one class 2. And then lastly, we can go ahead and say we have our method out here called output, and our method output is let's see, we actually call display answer. So our display answer will have the value coming back. So it's my added class.text. So now when I click the overload, I get class 1 comma class 2. So not only did it add the numbers together, it also added the strings together and it stored that result. So in this case, it's showing me that I've concatenated these two results at the same time I've actually added these two values. And that's all occurred because I simply told the two classes to add themselves to each other. So hopefully that gives you an idea of how operator overloading, how powerful it can actually be for code like this. Okay, back over to our slide deck. So today we covered operators. We looked at both the mathematical arithmetic operators as well as the assignment operators. We then moved into our logical and our relational operators. Don't forget there are a bunch of other operators, and I mean you're going to find them all over the C# language. And in this case, if you find one that is close to what you need but not exactly what you need, you can always fall down to the very last thing, and is that where you can that is where you can actually create your own idea, your own concept of what that operator should do for your particular set of code or your particular instance using the mechanism of operator overloading. I want to thank everybody for stopping out today and watching this webcast. Please, as always, feel free to send me an email, wsteele@microsoft.com, ask me any questions, or follow me on Twitter at wjsteele.com. I'm sorry, at wjsteele. And, you can even ask me questions there if you want. Tracy's going to go ahead and take you back out now to the survey. Please, please, please fill out the survey. Let us know what you like about this series and what you want to see us do in the future webcast series. And I'll see you all next week. Tracy?
Excellent. Thanks, Bill. What you should all be seeing now is the survey that Bill was talking about here. If you follow the links provided on the screen, that will take you into the evaluation. And we really do appreciate the feedback that you leave there for us. Please do take a moment to fill this out before you log off. Also, as a reminder, the slides are available as a print to PDF. You can go to the printer icon in the bottom right-hand side of your live meeting screen. You can either print or save the slide locally for your convenience. Also, today's presentation was recorded and will be available up on Microsoft.com/webcast within about 48 hours. With that, I do want to extend a very special thank you to Bill for presenting today. Ladies and gentlemen, that's going to conclude today's session. Thanks again for joining us. You can now disconnect from the audio portion of today's presentation.